We're not alone, and we're finally about to prove it. For most of human history, the idea of alien life was pure imagination. Stories, myths, science fiction. But right now, for the first time, science is closing in on a real answer. We are living in the first era where we can actually detect life on other worlds. And the evidence is stacking up in a way we've never seen before. To understand how big this is, we need to rewind just a few decades. In the early 1990s, we did not know for sure if any planets even existed outside our solar system. Astronomers suspected they did, but we had zero confirmed examples. Zero. Then, in 1992, everything changed. We detected the first exoplanets, planets orbiting another star. They were strange, harsh worlds, nothing like Earth. But that discovery cracked the universe wide open. Fast forward to today, we have found thousands of exoplanets. Big ones, small ones, hot ones, frozen ones. Some orbit 2 stars at once. Some are ocean worlds that might be completely covered in water. And a growing number sit in the habitable zone around their star. That's the distance where temperatures could allow liquid water to exist. And where water can stay liquid, life, at least as we know it, becomes possible. Think about how wild that is. For billions of years, Earth might not have been unique. Our galaxy is filled with worlds where chemistry could run wild. Where simple molecules might slowly organize into something that can grow, adapt, and maybe even think. So why do scientists sound so confident that we're close to finding something? It's not just the number of planets, it's the tools we have now, and the ones we're about to use. One of the biggest game changers is powerful space telescopes. You've probably heard of them. These are not just taking pretty pictures. They are sniffing the atmospheres of distant planets, light year after light year away. Here's how that works. When a planet passes in front of its star, a tiny bit of starlight filters through the planet's atmosphere. Different gases block different colors of light. So by studying that filtered light, scientists can figure out which gases are present. They are basically doing cosmic forensics on worlds they will never visit. Why does that matter for alien life? Because certain gases are powerful clues. We call them biosignatures. A biosignature is anything in a planet's atmosphere or on its surface that might be created by living things. On Earth, the obvious example is oxygen. Our atmosphere is full of oxygen, mainly because plants and tiny microbes keep making it. Without life, our oxygen levels would drop dramatically over time. So imagine finding a distant planet with lots of oxygen, or methane, which on Earth is often produced by bacteria and animals, or even a strange mix, like oxygen and methane together. That combination is unstable. Those gases should destroy each other unless something keeps replenishing them. That something might be life. Of course, nature loves to trick us. There are non-living or abiotic ways to create these gases too. Volcanoes, chemical reactions on rocks, powerful radiation from the star. So scientists are careful. One gas alone is never enough. They look for patterns. They run simulations. They ask, could geology alone create this atmosphere? Or does life explain it better? At the same time, we're exploring our own cosmic backyard, and the solar system is turning out to be far more interesting than we ever imagined. Let's start with Mars. Dry, dusty, cold. At first glance, it looks dead. But Mars was once warmer and wetter. We see ancient riverbeds. We see lake basins. We know that long ago it had liquid water on the surface. That's why we sent rovers. They're not just rolling around taking selfies. They're drilling into rocks, scanning for organic molecules, and trying to piece together whether Mars once hosted life. Not intelligent aliens, not little green men, but perhaps simple microbes, tiny, sturdy cells that might have thrived in ancient Martian lakes. If we find even fossil evidence of microbes on Mars, that alone changes everything. Because it would mean life arose twice in one solar system, once on Earth, once on Mars. If life is that easy to start, then the galaxy is probably teeming with it. And Mars is not the only suspect. Far out in the colder regions of our system, some icy moons are hiding global oceans beneath their frozen crusts. Take Europa, a moon of Jupiter. It has a thick shell of ice, but beneath it, there's a deep, salty ocean. There may be hydrothermal vents on its seafloor, spewing heat and minerals into the water. On Earth, those vents are crowded with life. Tube worms, clams, bizarre bacteria, all thriving in complete darkness. If that kind of environment can support life here, why not on Europa? Then there's Enceladus, a small moon of Saturn. It literally sprays its ocean into space. Huge geysers of water vapor and ice particles shoot out from cracks in the surface. Spacecraft have flown through those plumes. They've detected organic molecules, salts, even tiny grains that suggest hydrothermal activity. All the ingredients for a potentially habitable environment. Think about what that means. We don't even have to land on some of these moons to sample their oceans. We can fly through the plumes, collect the material, and look for signs of life directly. DNA-like molecules, complex organics, or chemical imbalances that life might create. Beyond our solar system, we are also listening. Radio telescopes are scanning the sky, searching for signals that might come from intelligent civilizations. So far, we have not heard a clear, confirmed message. But the search is still in its infancy. We have only just begun to listen carefully. And the universe is huge. That raises a haunting question known as the Fermi Paradox. If the galaxy is full of habitable worlds, where is everybody? Why don't we see obvious signs of large-scale, advanced civilizations? There are many possible answers. Maybe intelligent life is incredibly rare. Maybe it tends to destroy itself. Maybe the distances are just too vast and no one is sending strong, deliberate signals. Or maybe we have not been looking in the right way, or for long enough. But here's the key point. We used to debate these questions purely in the realm of philosophy. Now, we investigate them with data. We measure. We observe. We build better instruments. We push the limits of what we can detect. Every new planet we find, every atmosphere we analyze, every icy moon we sample, all of it tightens the net around one of the biggest questions we can ask. Are we alone? We might discover that microbial life is common, but complex life is rare. We might find that many planets have the right conditions, but life just does not start easily. Or one day, we might find something jaw-dropping, a chemical signature we cannot explain without life. A repeating signal from deep space that carries structure, meaning, maybe even information. Even a tiny sign of simple life would be monumental. Because it would mean life is not a miracle confined to one blue planet. It is a natural outcome of physics and chemistry. Given the right conditions, the universe makes life, over and over again. Right now, new missions are being planned and launched. New telescopes are coming online. New techniques are revealing details in distant worlds we once thought were just points of light. We are not just asking if aliens exist. We are building the tools to find them. We are very literally on the verge of reading the atmospheres of other Earths and exploring hidden oceans beneath alien ice. When future generations look back, they may see our time as the moment the question shifted from "Do aliens exist?" to "What are they like?" and how many different forms can life take? Cosmic secrets do not stay hidden forever. Bit by bit, photon by photon, we are decoding the universe. And with every new discovery, one thing becomes clearer. The answer to whether we're alone is out there, and we are closer than ever to hearing it.